The heart-shaped propulsion system is designed to fit in a wing of an aircraft, and there are 4 of them, 2 in each wing of the aircraft, that weighs 45 kilograms on wheels. They have 4 projectiles that weigh 4 kilograms each in the system, which juggle with the projectiles to provide the forwards force. Let's calculate the net force exerted on the aircraft by the heart-shaped propulsion system. Given: mass of the aircraft 45 kilograms, mass of each projectile 4 kilograms, number of projectiles 4. Number of wings with propulsion systems 2. First, let's calculate the total mass of the projectiles. Total mass of projectiles 4 kilograms times 4 equals 16 kilograms. Next, let's calculate the total mass of the system. Chassis plus projectiles. Total mass of the system is 45 kilograms plus 16 kilograms equals 61 kilograms. Since the system uses a juggling effect with the projectiles to provide the forward force, the projectiles are continuously cycled and refired. This means that the projectiles are effectively providing a continuous propulsion force. To calculate the net force exerted on the aircraft, we can use Newton's second law of motion. Net force, F_net, equals total mass of the system times acceleration, We need to determine the acceleration of the system. Since the projectiles are continuously cycled and refired, we assume that the system accelerates uniformly over time. Let's assume a time interval of 1 second for the projectiles to be cycled and refired. Within this time interval, each projectile will be fired once, resulting in a change in momentum. The change in momentum for each projectile can be calculated using the formula. Change in momentum equals mass of the projectile times final velocity of the projectile. The final velocity of the projectile can be approximated as the velocity at which it is being fired, which is not explicitly provided in the question. Let's assume a final velocity of 50 miles per hour, 22.35 meters per second, for each projectile. Change in momentum for each projectile equals 4 kilograms times 22.35 meters per second equals 89.4 kilograms meter per second. Since there are 4 projectiles, the total change in momentum for the projectiles in 1 second is total change in momentum for projectiles equals 89.4 kilograms meter per second times 4 equals 357.6 kilograms meter per second. Now, we can calculate the acceleration of the system. Acceleration, equals total change in momentum for projectiles, total mass of the system. Acceleration, equals 357.6 kilograms meter per second, 61 kilograms approximately equals 5.86 meters per square second. Finally, we can calculate the net force exerted on the aircraft. Net force, F_net, equals total mass of the system times acceleration, F_net equals 61 kilograms times 5.86 meters per square second approximately equals 357.46 N. Therefore, the net force exerted on the aircraft by the heart-shaped propulsion system is approximately 357.46 newtons. Keep in mind that this calculation assumes ideal conditions and neglects factors such as air resistance and the specific details of the system. Inertial Propulsion Systems by Matthew S. Roberts. This was made using Tome. Inertial propulsion introduction. The concept of inertial propulsion is based on the principle that a body in motion tends to stay in motion. In this propulsion system, there is no need for any external force or fuel to move an object. Instead, it uses the inherent inertia of an object to generate thrust and propel it forward. This technology has been explored in science fiction for decades, but recent advancements in materials science and engineering have made it a reality. Inertial propulsion has the potential to revolutionize space travel by eliminating the need for heavy fuel tanks and reducing the cost of launching spacecraft. Inertial Propulsion Systems Review. The study of inertial propulsion systems is a fascinating field that has captured the attention of many researchers and engineers. These systems use the principles of physics to generate motion without the need for external fuel or thrust. They are based on the idea that an object in motion tends to stay in motion, and can be used to create movement in a variety of different ways. There are many different types of inertial propulsion systems, each with its own unique set of advantages and disadvantages. Some of the most common types include gyroscopes, flywheels, and reaction wheels. Each of these systems uses the principles of angular momentum and torque to generate motion, and can be used in a wide range of applications, from spacecraft propulsion to industrial machinery. Inertial mechanics. Inertial mechanics is the study of the motion of objects that are subject to forces and torques. It is a fundamental concept